Bond Energies worksheet. In this question we're working out the energy change of a reaction. So the first thing we need to do is work out the energy change as the bonds are being broken. So when we break the bonds, we've got a carbon to hydrogen, well we've got 4 of those, so that's 4 lots of 413 kilojoules per mole using this data table here. But there's also a chlorine to chlorine bond here which we need to break, which is 243 kilojoules per mole. So the total energy used to break those bonds is 1895 kilojoules per mole. Now we're going to work out the energy change or the energy released when these bonds form. So exactly the same process, but here we've got the same data table, but we've got carbon to 3 hydrogens, so that's 3 lots of 413 kilojoules per mole. We've got 1 carbon to chlorine, and we've got 1 hydrogen to chlorine bond, so we need to add the 432 and the 346, giving a total energy here, which is released, of 2017 kilojoules per mole. Now the overall reaction is the energy required to break the bonds take away the energy released, and that'll give us minus 122 kilojoules per mole. So make sure when you put the answer in, if it comes out as a negative, you put in there -2. Question 1.2, that asks us, explain in terms of bond energies whether the reaction is endothermic or exothermic. Well, we know that it's exothermic because more energy was released than was needed to break the bonds of the reactants. Also, you can point out that as this is negative, then that's definitely going to be an exothermic reaction, but obviously it asks in terms of bond energies, but both of them tally up with each other. In this very challenging question, it's a grade 7 to 9 question, you're asked to find out the hydrogen to fluorine bond energy. So we've got the reaction here, hydrogen plus fluorine makes 2 molecules of hydrogen fluoride. So the first thing we need to work out is the energy required to break this hydrogen bond, hydrogen-hydrogen bond and the fluorine to fluorine bond. Well, we can work that out as adding the 2 together makes it 594 kilojoules per mole. Now we've got the first part worked out, we know the overall energy in a reaction is the energy required to break the bonds minus the energy released when the bonds are made. So if we rearrange that equation, the energy when bonds are made is equal to the energy when they're broken minus the overall reaction. So putting this into the equation and being careful of this negative sign here using brackets, the energy released when the bonds are made is 1136 kilojoules per mole. Now we have that information and we know that the energy released when the bonds are made is 1136. We know that there are 2 hydrogen to fluorine bonds here, so all we have to do is divide that 1136 by 2, meaning that each individual bond has a bond energy of 568 kilojoules per mole, and pop that into the answer.